In this section, we are going to start with something called layer 2 connections over the WAN using Ethernet lines. Like in general, if I just take an example of any one of the WAN technology. Now, when you talk about WAN connections, we got many types of WAN connections. We got something called lease lines. We have a separate dedicated connection between the two routers. We got something called frame relay, MPLS. So we got many type of WAN technologies. So here we are going to see is one type of WAN connections over Ethernet lines. So if you are establishing your WAN connection over Ethernet lines, now how we are going to do that? By using a separate VLANs trunking concepts. Now this will be very useful, especially when we are using some WAN connections like metro Ethernet lines. If you are using over Ethernet, we are establishing a WAN connection, or it can be very useful especially in your CCIE lab exams. In your CCIE lab exam, you have a logical diagram which is representing router 1 is connecting to router 2, or router 2 connecting to router 1, and in between you have some switches involved where we are going to keep this port in the same VLAN, just more like a normal layer 2 connection. So that is something what we are going to learn in this section. So we are ready to start with our first thing. So before we get into these things, the first thing I want you to know the pre-requirement of this thing. So before we get into these complete sections, I expect you to know some basic configuration of the VLANs, how to configure the VLAN, like by using switch port mode access, switch port mode trunk commands, and then the trunking configurations, and also using some inter-VLAN routing when you are using a router by using sub interfaces here for multiple VLAN. That's what we did, some basic labs in these things in our basic switching concepts. And also you need to have a very good understanding on how to create SVIs on your layer 3 switches. So based on this, we are going to create some logical topologies here. Now, especially these concepts are useful in your metro Ethernet lines and even in your configuration section, where most of the WAN connections are built over the Ethernet by using these logical connections. Let us see how to do that. This is the standard default topology which I am going to use here. This is a default topology which I already connected here, where router 1 interfaces all F0 by 0s or connecting to my switch 1. You can see all the 5 ports. I'm using 5 devices: router 1, router 2, router 3, router 4, and router 5, and all are connected to my switch 1 interface. So this is the default physical topology. So you can see here all F0 by 1 is connecting to router 1, F0 by 2 connecting to router 2, 0 by 3, 0 by 4, 0 by 5. So simply by seeing this number, the port number, I can understand what is the opposite side interface or opposite side device. So it's router 5. So I just try to connect the devices in a serial fashion so that we can easily remember which side of which port is going on which router here. And similar way, the router 1 is connecting all F0 by 1s or connecting to my switch 2. I got a connection to switch 2 here. On the switches, I use the similar kind of ports like F0 by 1 connecting to router 1, F0 by 2 connecting to router 2, F0 by 3 on the router 3, 4, and 5. So this is the default topology which I'm using. And between switch to switch, here you can see port number 23 and port number 24. So these two links are actually connecting to my switch to switch, and these links will be acting as my trunk links. So these are the trunk links which I'm going to use for allowing that VLAN traffic over these trunk links. So let us see how the things are going to work here. So the first thing, we will try to understand the logical topology of router 1, router 2 connecting to router 5. So now if you see the default physical topology, here we don't have any connection between router 2 and router 5. So but if you see the next diagram, this is my logical diagram which is representing that router 2 is having a connection to router 5. But as per our physical topology which I have said, there is no direct physical connection between router 2, this is my router 2 here, and router 5. You can see there is no connection here, but we are saying these two devices are connected. How they are connected? So let us see. So router 2 is connecting to switch 1. So first thing, we need to analyze what is the kind of port here. If you see my diagram here, router 2 F0 by 0 connecting to F0 by 0, which means on both the ends I'm using F0 by 0, which means router 2 is connecting to F0 by 0 here. It is connecting to switch 1, that is on F0 by 2 port, and from there it is on the same switch connecting to port number 5, again connecting to my F0 by 0. So which means the router 2 is having a connection to router 5 via your layer 2 switch. So that is the default physical connection. This is the default physical connection is from here. This is your default physical connection. Router 2 connecting to router 5 here. This is my router 5. Just a minute, it's not router 2, this is router 2. Okay, so I just got my labels in the bottom here. This is router 1 and this is router 2 here. So router 2 connecting to my router 5 here. So let us see how to do that. Now, as per our default physical topology, router 2 F0 by 0 ports is connecting to switch 1, and then this is also F0 by 0, again it is connecting to switch 1, and then on the switch 1, this is my router 2 port, which is F0 by 2, and this port is F0 by 5 here. So which means in order to make sure that router 2 is connecting to router 5 directly to each other, but physically they are not directly connected, they are connected to switch, which is my intermediate devices, we have to make sure that these two ports, which belongs to F0 by 2 and F0 by, should be a part of same VLAN. So this is how logically we separate the connections between every two devices, even though physically they are not directly connected, but logically we are representing them as a part of a separate broadcast domain by making them in a separate VLAN. Okay, so that is something what we are going to do here. So that is really good to understand the logical connections here. Now similarly, I got another diagram here, like here one more diagram. So this is all the diagrams, we'll see the things practically here. Okay,